isn't it? Is it clear?
Yes, ma'am.
All right. So suppose someone asks you to write a code in MATLAB software to find the roots of the polynomial equation that have one variable, and this polynomial equation should be non-linear. Okay, so how do you find the roots of the polynomial equation that is non-linear and that have only one variable? So the procedure is, suppose you have this polynomial equation x cubed plus 4x minus 3. So x cubed plus 4x minus 3, this is equal to 0. You get this polynomial equation. So next step B, you have to rewrite this equation according to the power of x that is decreased 1, isn't it? That is decreased with 1. So let's see, what is the maximum power of x? This is 3. So you have to write this on here. Next term will be x to the power 2. Do you see? Okay, I repeat. You have this polynomial equation. This is non-linear. And this equation have one variable. So what is the maximum power of this variable? 3, right? So you have to write this polynomial in this form when you get the power of variable should be decreased by 1. So let me do it for you. 3 minus 1, that is multiplied with 0. So do you get any difference? Do you get any difference? 4 times x to the power 3 minus 2. That means you get x to the power 1. Then minus 3 times x to the power 3 minus 3. This is equal to 0. So you have now this polynomial equation form like this: x cubed plus 0 times x square plus 4 times x minus 3. This is equal to 0, isn't it? So if you want, you can skip this step. It's up to you, because when you understand the procedure to make these polynomial equation format, then you can avoid middle steps. So what do we get now? Now you have to take the coefficient of x cubed, because x cubed is the, like, these 3 is the maximum power of x. So you have to take the coefficient of x cubed. Next you have to take the coefficient of x squared. Next you have to take the coefficient of x, and next you have to write these constant value. Alright, because this is the coefficient of x to the power 0, isn't it? So you have to take the coefficient of these variables that have that will start from maximum power of variable, and that should be decreased by 1. So you can store these coefficient in the name, suppose p. So you can store these coefficient like this: 1, then a space, then 0, then a space, then 4, then a space, then 3. You already stored these coefficient that comes from the provided nonlinear equation in one variable that is stored in variable p. Now you have to call this p to find the roots. So you can do the operation like this. SOL that gives you solution. Okay, this is equal to a small r WTS of, you have to call this function that comes here p. Then if you run this code, then so you get one real root. Look at here. This is real root because these 0.6736 plus 0.00 times I, that means this is real root. 0 times anything that becomes 0. So you will get finally 0.6736. This is real root, and another two roots are complex. So I think you will be able to predict number of real roots, number of complex roots if I give you nonlinear equation in one variable. So here is the exercise problem where you have to find the number of real roots of each equation in the given interval. So suppose for this question, if I mention somewhere the interval, I mention here the interval like this, 0, then 3. So what will be the required answer? What will be the required answer? In this interval, which root exists? In this interval, which root exists? Only this real. Otherwise, you won't get correct answer based on the question. Practice this question because similar type question could be arise in any assessment. Sometimes someone asks you to predict number of real roots. Sometimes someone asks you to predict the number of complex roots. Okay, sometimes yeah, we can ask you to predict the degree of the polynomial equation. That's it. So next, by how do we locate the roots? How do we locate the roots? That means here you have to find the region of the roots. So by using graphical method, you can predict, okay, here the real root exists, here another real root exists, here another real root exists, here another real root exists. So based on this graph, you get, okay, we have 4 real roots. That's good. So now you have to predict the region of the roots. That means you have to find the interval of the roots, and that interval should be open. Okay, so how do we find it? So if you have a polynomial equation, then you can define y equal to the polynomial f of x. So x is independent variable, y is dependent variable. So you have to consider 2 independent variable values. That means you have to consider 2 values of independent variable, as simple as. So you have to consider 2 values of independent variables so that f of x some are positive, f of x will be negative. Suppose you consider x equal to a, and you have to find f of a value. If you get f of a value, this is negative, that means you get this y value below x-axis, isn't it? If you get this is negative value, suppose -1, suppose -1, so this is equal to y. So when x equal to a, you will get y equal to -1. That means y value should be exist below x-axis. All right. Sometimes you can get for x equal to 0, y becomes of x is positive, and for another x value, f of x will be negative. Look at here. And when you get, suppose for these x equal to a, you get f of x, this is positive value, and here, suppose here you get f of x value, this is negative for x equal to any value. So this curve crossed x-axis. So at this point you can get real root, isn't it? And this is called real root of this polynomial equation. So next you have to think, okay, so f of x is continuous, this function is continuous, right? So what is the difference between continuous function and discontinuous function? Suppose this one, so you can define this as f of x function. So this f of x function is not continuous because here you see empty space, right? You can see these two curves distract from here, exactly from here. So this is discontinuous function, but you have to remember the function should be continuous and in the interval that is considered a comma b, and you have to find f of a negative. Sometimes you can get f of b positive. That means this f and this f are opposite sign. Okay, these two function carries opposite sign values or opposite like positive. Like if you get positive value for f at the point a, you should get the function value that is a negative for the point b, so that you can predict at least one real root exist in the open interval a comma b, because you consider a here, you consider b here to derive functional value, and you can get f of a times f of b that is less than 0. So these conditions should be satisfied to find the location of roots. Sometimes you can get, okay, these criteria doesn't exist or work. So what we should to do? So when these criteria doesn't work for the provided function f of x equal to 0, you have to do first time derivative of f function with respect to independent variables so that you can get f prime x. When you have f prime x, you can easily calculate f prime of a and f prime of b. You can easily This is the open interval, and in this region the root exists. So this is the theory. So just apply the theory here to solve these sample question. So the equation this one has two real roots. So sometimes you can see the number of roots are given to you for the provided nonlinear equation in non-variable. So how do you predict the interval for each roots? How do you predict the region or interval for each root? So how do you predict it? The process here, you have to rearrange this equation to find function or define function. So from this equation, you can easily get f of x function. Let me do it for you. So you can define this is f function of independent variable x. This is equal to 0. So you can write f of x equal to x minus 1 e to the power x minus x, isn't it? So how do we predict the interval? So what is the independent variable here? X, isn't it? So you have to substitute x value in this functional expression so that you can get f of x function at each x value. Minus 1 value, isn't it? So if we consider x equal to 0, you will get y equal to minus 1. Suppose minus 1 here. That means the point exactly this one. For x equal to 0, you will get y value. This is minus 1. Next, so suppose this is minus 1, this is minus 2, this is minus 3, this is minus 4. This is the scaling of x-axis. So similarly, you can define this is your plus 1, this is plus 2, this is plus 3, this is plus 4. It will continue till positive infinity. So at x equal to 0, you get y equal to minus 1. That means this point. So you get functional value below x-axis. Now you have to find some functional value that gives you positive value. Okay, that means that function could be exist above x-axis. So you have to consider x value. So suppose you can consider x equal to minus 1. If you consider x equal to minus 1, what do you get? If you consider x equal to minus 1, you will get f of minus 1. This is equal to minus 1 e to the power minus 1 minus of minus 1. So you will get 0.2. This interval, because you consider this is A, this is B point. So let me check what is about f of A minus 1, that times f of B 0. So what will be the value you can get? 0.26, that times minus 1. This is equal to minus 0.26. That should be less than 0, isn't it? That means in this interval, one real root exists. Is it clear? Is it clear to you?
Yes, ma'am.
Yes, ma'am.
Okay. How about other interval that could be possible? So you can consider this is another interval. This is another interval. That means you can define -4, -3. This is one interval. You can define -3, -2. This is another interval. You can define -2, -1, another interval. And you already check this interval, isn't it? So, and in this interval, on real root exists. Move on rightwards of x-axis. So, how about interval 0 to 1? Isn't it? So, 0 to 1, this is one open interval. Then you can get another open interval 1 to 2. Or open interval like 0 1. Okay, so 0 1, so this can be defined by a, this can be defined by b. Okay, so you can easily get f of 0, this is equal to -1, and you get f of 1, that is equal to -1. So look at here. So just do simple multiplication between them. What do you get? You will get now f of 0 times f of 1. This is equal to +1. That should not less than 0, isn't it? So this condition doesn't satisfy. F of a times f of b less than 0. This condition is not satisfied because you get here greater than sign, isn't it? So you just sure, okay, you can get, okay, in this interval 0 to 1, in this interval you can't get any real root of the provided polynomial equation. So move on next to value 1 2, or next to number of x, or next to value of x. So 1 to 2, if you consider from here, so you don't get a real root in this region. So next, just to move on, next region here 1 to 2. Let me check. So you already have f of 1, this is negative value, and if you substitute x equal to 2 in this function, you will be 1 2, and another interval be -1 0. Okay, so in these two interval you will get two real roots. Now is it clear? Look at here, this is one interval, this is another interval, and two real root exist in this interval. One real root exists in this interval, another real root exists in this interval. So you get two real root that exist in this interval respectively. So by following this process, you can only get the location of real root. You don't get real root exactly. You get only the region or location of real root. So how do you find real root? Yes, you can predict or define real root by using bisection method. So this is the algorithm of bisection method. So you already know what is the process to predict the region or interval of real root, isn't it? Suppose a comma b, this is the interval of real root or region of real root. So what will be discontinuous, then only you have to choose two approximations a and b such that f of a times f of b that is less than 0. That means a real root exists in the open interval a comma b, isn't it? If you get somewhere f of x is not continuous, so you won't be able to predict a real root by using this bisection methodology. So when you get this condition is satisfied, you have to move on next step. Here you have to predict or find the midpoint C for the open interval a comma b. So how do you get the midpoint? So if you consider C is midpoint, so you can derive the midpoint by using this formula. Just add these two numbers and just do division operation by 2 of it, then you will get midpoint. If you get midpoint C, then you have to check f of C is equal to 0 or not. If you get f of C equal to 0, you can conclude easily C is a root of f of x equal to 0. Alright? Because you have f of x function, this can be continuous in this closed interval, so you can write y equal to f of x, or you can write f of x equal to 0. Alright, that's why this f of x equal to 0 can be written here. Next, so if you check these criteria. So suppose you get A and B. Suppose A is here, B is here, and you define C is the midpoint. So when you get f of C that is not equal 0, that means you have to consider these two interval, and you have to predict in which interval real root exists. So if you see f of A times f of C, that means if you substitute A value instead of x, if you substitute C instead of x, and if you do this operation f of A times f of C, if you get that is less than 0, that means real root exists in this interval, in this open interval, isn't it? And if you get somewhere f of C that is multiplied with f of B that is less than 0, that means a real root exists in this open interval. Alright, so if these conditions satisfied in third step, then you have to move on next step, and here you can easily do some iteration, because you have to check formula or iterative formula. This one x suffix n plus 1, this is equal to an plus bn divided by 2, and this n should be start from 1, remember. So suppose n equal to 1, so what will be x value? X2, this is equal to a1 plus b1 divided by 2, and from where you get ab, at the beginning you consider these closed interval, and these from this closed interval you get open interval, and these have already you have x on x2, so you can do these subtraction operation, then you can do easily absolute of it and check the findings. Is it less than or equal epsilon or not? If you get this value less than or equal epsilon, that means this epsilon gives the accuracy value. So if this is less than equal epsilon, then you can stop, just stop the procedure right now, and this x2 is the real root of the polynomial equation. Here you get an example. So where you have to find the root of this polynomial equation by using bisection method. So you already know the algorithm of bisection method, and accuracy is given to you, and you see the interval. That means this is your A, this is your B. Okay. So how do it, like, look at here, in this table you get several rows, isn't it? So in each row you have to write them down here. A equal to 1, B equal to 2. Next, what you should to do, you have to find, okay, let me write it down here. So you have to insert A value, this is 1.0. You have to insert B value, this is 2. Next, you have to predict what is the value of f of A. So you already have A value 1, so you have to insert one value instead of x. That means like this, isn't it? So you have a value, f of a value, this is -2. Similarly, you have to predict f then you have to take this value, then do just division operation by 2 of 8, then you will get c value. When you get c value, you can easily find f of c value. So f of c equal to -0.75. Okay. So next you have to do this multiplication operation, f of a times f of c. So if this is greater than 0, if this is greater than 0, you have to write a equal to c. That means this c value will be shifted in a f of a times f of c. This is greater than 0. When you get this is greater than 0, then you have to write a equal to c. That means c should be shifted in a position. So what is about c? 1.5, isn't it? So now a is 1.5 and b should be same, because we didn't get any other condition for changing b value. So b should be same. So now your interval is this one, isn't it? That means this given interval will be shrinked. So next you have to find f of a, you have to find f of b, you have to find midpoint. So what is the midpoint for 1.5 comma 2 open interval? So midpoint b 1.5 plus 2 divided by 2, isn't it? So midpoint b right now 1.75, isn't it? So you will get easily f of c value. Then you have to do f of a times f of c operation. So what is about f of a? So you can get f of a from here, you can get f of c from here. Just do simple multiplication operation. So you get, suppose, less than 0 value. So for this case, you have to write b equal to c. That means the c value will be shifted in b position, 1.75. So look at third row here. This b value, sorry, this c value. See, where is c? This value. operation between them, you will get 0.5. So because a equal to 1 and c equal to 1.5, so you can easily get the difference between these two values. Then similarly, you get here the relation b equal to c that depends on these relations. So you can get these difference. Just do simple operation. What is about c? What is about c? 1.75. That minus b. So what is the value? So you have to take absolute value of it, right? So 2 minus 1.75, that gives you 0.25. If you do this operation 1.75 minus 2, then you will get minus 0.25. You have to take absolute value of negative sign. Okay, then you get 0.25. Similar process have been done here. So you have to check the accuracy. Look at this accuracy value. This is 0.5. That is very far from this given accuracy, because 0.5 is very big number compared to this 0.01. So you have to do same calculation for getting these difference value that very close to this accuracy number. So look at here, 0.0078, isn't it? So you get this is very f of c should be less than 0, isn't it? So you have to stop the calculation exactly here, because you get in next row f of a times f of b that's greater than 0. Although we get very small number that is close to accuracy. So what is the root? This is the root of the polynomial equation. So here is the exercise problem. Please try to apply the bisection method to predict the root of this polynomial. Somewhere you get the interval, so please check it and try to practice a lot as much as you can. Here you get advantages and disadvantages of the bisection method. Please try to read this on. Don't worry, because sometimes someone asks the advantages of bisection method. Someone asks you what is about the disadvantages of graphical method. Okay. So here is similar question. So similar type question could be arise in any assessment. Suppose you get the polynomial equation and you have to find the degree of the polynomial. So what is the degree of the polynomial? 4, because from this polynomial equation you get x is independent variable and the maximum power of x is 4. And next, here you have to apply graphical method to find the number of real roots. Here you have to apply graphical method to find the number of complex root. And look at this question. Here this function that is continuous, and this function is continuous. So how do we calculate this f of 2? You just insert x equal to 2 in this function. Then you will get minus 1. So answer should be minus 1. So because yeah, you can see similar question in any assessment. Okay, practice a lot as much as you can. Why? Oh my god, charger doesn't work. Okay, anyway, next I'm going to move on to discuss about second method and Newton-Raphson method. Yes, you can apply second method and Newton-Raphson method to solve nonlinear equation in one variable to get the root of the provided nonlinear equation. So how do we apply it? Look at this algorithm. So in second method, you have to follow these formula: x suffix n plus 2, this is equal to this, and remember this n value start from exactly 1. So you get, okay, n value start from 1, and these formula, this is an iterative formula. You can easily notice it, because x suffix n plus 2 and the n value start from 1, so it will be iterative formula. So how long we have to do calculation? Differentiate, you can do easily subtraction operation between x3 and x2. So you will get the difference between two successive x values. Then you will get absolute value of this difference, and you have to check, does it less than equals epsilon or not. If you get these condition is satisfied, then you have to stop the calculation. So far, here is the example. Okay, so suppose you have to find the root of this polynomial equation. You have to apply here second method, and you get the accuracy value, and you have x1 and x2 value. So how do we get the root of the function f of x when we see the accuracy value is given here? So just okay, so you have x1 value, right? You have x1 value, you have x2 value. If we apply these formula, then you will get, consider n equal to 1, because n value start from 1. So what do you get? You get x3. You get x3 value. When you consider n equal to 2, you will get x4 value, right? So when you consider n equal to 1, you get these x value, and for this x value you have to calculate functional value, and when you get functional value, that should be okay. Next step B, you have to find the difference between this value and this value, then you get this absolute value, and you have to move on. Next step, because you have to do same operation again, because look at this accuracy. This value is very far from this accuracy, isn't it? So you can see this accuracy value decreased, so it's very close to this accuracy. So this is the root of this given nonlinear start from 0. For second method, n value start from 1, and for Newton-Raphson method, n value start from 0. Alright, so you have to follow these algorithm for getting accuracy. Alright, for getting close to accuracy value. So for Newton-Raphson method, only one gauge value exists, and for second method, two gauge value exist. Remember this one. So just similar type question could be arise in assessment, where you have to perform one iteration by using Newton-Raphson formula, and you get you have to find the roots that is near to x equal to 0. That means this is your x0 value. Alright, so if you apply these Newton-Raphson formula, like substitute n equal to 0, what you can get? 0 plus 1, that means x suffix 1. This is equal to x naught minus f of x naught divided by f prime x naught. So if you have f of x polynomial equation, this is equal to 0. So you can easily do first time derivative of f with respect to x, isn't it? So just substitute x value here like x naught, because initially you have only one guess value. Next you get x on value by substituting x naught, f of x naught and f prime x naught here. So when you have x on, in that case you can easily do this subtraction operation. When you consider n equal to 1, that defines second iteration. So just after doing first iteration, you will get x value, this is 0.25. And you can apply F0 command to find the root of this polynomial nonlinear equation that have only one variable. So you have to define the function earlier to call the function, and you have to write here the interval or mention the interval where this root exists. All right, then you can easily get the solution of the nonlinear equation by using Newton-Raphson formula. Okay, so you get here advantages and disadvantages of it. You can get some sample question. So please try to practice. If you have any problem, just let me know. Okay. So here you see some exercise problem where you have to do iteration. It could be 2 times, it could be 4 times, and here you have to apply Newton-Raphson method. And you look at here, somewhere it can be defined like this. You have to find the root that should be estimated up to 2 decimal places. So what is the meaning of it? If I define here, find the root up to 2 decimal places, find the root of this nonlinear equation in one variable up to 2 decimal places. So right answer should be 0.25 based on this requirement. So I think this is enough for today. So anyone have any question? If you face any problem to understand anywhere based on the discussion topics today, please let me know. So you can leave message from your student ID, then I can fix time and we can discuss the problem if you mention. Okay. So thank you everyone. Yeah. So I will upload marks in portal very soon. Anyway, I will provide or return this answer script after checking one by one very soon. So don't worry at all. So all the best. So you can leave the class as soon as possible.